Okay, this is Algebra 2, Lesson 26. In this lesson, we are going to talk about more factoring and some more overlapping of triangles. Now, look at example 26.8. When we factor, we're basically undoing multiplication, right? And we said earlier that the inverse of multiplication is division, and the inverse of division is multiplication. So when we're factoring, we're really undoing the multiplication by dividing out a common factor, a greatest common factor. So if you notice, they showed you three different examples, A, B, and C. And in the first one, A, if you notice, they all have a pattern. The first term, it's the product of the first terms of the binomials. The last term is the product of the last terms of binomials. And then the coefficient of the middle term is the sum of the last terms of the binomial. So, to factor a trinomial whose lead coefficient is 1, we need to find two numbers whose sum and product meet the requirements of B and C. So basically, let's look at this one, x squared plus 6 minus 5x. The first thing we do is we're going to put it in order. So we're going to go back and do x squared minus 5x plus 6. So we're going to start off with two parentheses. Okay, because we have, what is the product of two numbers that equal a positive 6? 2 and 3, 1 and 6. Those are options. They either have to both be positive or both be negative. So we know we're going to use one of those two combinations. The next thing we're going to do is we have to look at the middle term. It's a negative 5. So the sum of these two has to equal that. So we definitely know we can't use this one. This one gives us the right sum. It's the wrong sign. So that both have to be negative, and then I get a negative 5. So we simply have x minus 3 and x minus 2. And you can write it in either form. It doesn't matter. Okay, so let's look at the second example. We have negative x squared plus 5x plus 14. Well, I want to start off by factoring out a negative 1. So I simply have x squared now minus 5x minus 14. So I still got to keep this negative out here. And I'm going to start off with two x's. And what are the products of 14? You have 1 and 14, 2 and 7, right? Well, because this is negative, one has to be negative, the other has to be positive. So those are your combinations. Now we said the sum of these two has to equal to the middle term, the coefficient. So this is going to give me 13, negative 13. So these are out. This is going to give me a positive 5. This is going to give me a negative 5. And what do I need? I need a negative 5. So I need this one. So I have x minus 7, x plus 2. Now you can leave your answer like this with a negative 1 on the outside, or you simply can distribute to one of the two factors. So I'm going to do it for this one. So I can say negative x plus 7 times x plus 2. That's one way. That's another. Another way is x minus 7. We'll distribute this to that one. Negative x minus 2. Any of these three are all correct. Okay. So let's do another one. Let's factor 26.3. It says 24 plus 6x minus 3x squared. So the first thing I want to do is I want to put these in order. So I'm going to rewrite it. 3x squared plus 6x plus 24. And when I talk about order, I talk about degree. Remember, we learned the degree is the highest power of each term. So the highest power is 2, because 3 has a degree of 0. So 2, this is a degree of 2, degree of 1, and degree of 0. So we're going to put them in order that way. The next thing I would do is I want to make my lead coefficient 1. Can I do it? Is 3 a factor of all the coefficient of all three of these coefficients? Yeah, so if I divide out a negative 3, I'm going to get x squared minus 2x minus 8. So basically I took each one and divided by negative 3. That's all I did. And this is what I get. Now I can factor -3 times x. What are the products that make 8? 1 and 8, 2 and 4. Now we have a negative, so you have to have these choices. Negative. One has to be negative, one has positive. Now the sum of these two have to equal to that. This gives me 7, so I know right off the bat those two are out. This gives me a positive 2, and this gives me a negative 2. Well, I need a negative 2, so therefore this is what I want. X minus 4, x plus 2. And that's simply your answer. Then if you wanted to go back, you can leave it like that, or you could distribute the -3 to one of the two factors. Okay? So let's look at another one. Let's look at example 24 point, I believe it's 26.4. So it's 32x squared plus 12x cubed minus 2x to the fourth. Well, the first thing we do is we're going to write this in order. So it's negative 2x to the fourth plus 12x cubed plus 32x squared. Then I say, can negative 2 be divided into each one of these terms evenly? Yeah, so if I take out a negative 2, then I can take out an x squared, just like we did in the previous lesson. Okay, so this becomes x squared minus positive divided by negative is a negative 6x minus 16. And if you're not sure how I got that, basically I took each one of these terms and I divided by negative 2x. And it's simply using your exponent rules and division. Simple division. 32 positive divided by negative is a negative 16. That becomes, oops, we took out an x squared. Sorry. Okay, so now I can factor this. Well, I start off, I got to keep this. I can't lose this. And then I'm like, what are the factors of 16? 1 and 16, 2 and 8, 4 and 4. Well, it's negative, so I have to have one positive, one negative. Here, because of the same numbers, it doesn't matter. Okay, it doesn't change. So now I need to know, what does the sum need to equal to of these products? Well, we look at the middle coefficient, negative 6. Well, I know this gives me 15. Those two are out. These two give me 6. This gives me 0, so this is out. So I need a negative 6. So listen, this gives me negative 2 and a positive 8 is positive 6. Negative 2 and a positive 2. Negative 8 and a positive 2 gives me negative 6. So this is the one I want. So I have x minus 8 and x plus 2. And that's it for factoring. You leave it like that. Now let's look at overlapping triangles. We've already looked a little bit about them. We're going to learn a little bit more. So let's look at this right triangle. Okay, we're going to pretend like mine is a right triangle. We're going to find ways to use the Pythagorean theorem to find missing sides. Okay? So we look at this, if we draw them separately, we know that they have a common angle 8. Let's draw these separately. We get 6. Oh, there's 4 in here. 4 and A. Then we get C, A plus B, right? A plus B. And this is 6 plus 4. So now we can say this is 10, right? It's a big triangle. So can we find A over here? Yes, we've got a right triangle, and we know A squared plus B squared equals C squared. So what is my A? 6 squared plus 4 squared equals 6C squared. So 36 plus 16 equals C squared, or 52 equals C squared. C squared is, so C is equal to the square root of 52. So this is square root of 52. So now we know that this is the square root of 52 plus b. Yes? So can we find c? Easily, we know scale factor. Don't we want to know the scale factor? Because we know this is 10, so 6, these are the same, times the scale factor equals 10. So we divide by 6. The scale factor is equal to 5/3. Okay? So can we find C right here? Yes. We simply take 4 times the scale factor to give me C. So C is equal to 20 over 3. So I've got 20 over 3. And I said A is the square root of 52. So now, can I find B? Yes, because now I use my Pythagorean theorem, and I say square root of 52 plus B squared plus 10 squared equals 20 over 3 squared. Yeah? Or we could do it that way, which that's a long way, or we could use a scale factor. We said the scale factor was what? The scale factor is equal to 5 over 3. Okay? So, we know square root of 52 plus b times the square root of 52 equals square root of 52, we take square root of 52 times the scale factor, yes, is equal to square root of 52 plus b, right? This times the scale factor equals that because those two are the sides that are proportional. So now we can just simply multiply the whole thing by 3 because I want to get rid of my numerator. So then I simply get 5 square root of 52 equals 3 square root of 52 plus 3b. Well, I'm going to subtract 3 square root of 52 from both sides. This gives me 2 square root of 52 equals 3b. Then I divide both sides by 3, and I get b is simply 2 square root of 52 over 3. So now I got A, I got B, and I got C. So that's B. If I want to get this whole side, I simply add B to A, which is square root of 52. And I add them together, and that's my answer. Okay? So we have square root of 52 plus 2/3 square root of 52. Well, you have fractions. I have to get a common denominator, don't I? So I'm going to multiply by 3, yes? For 3. So 3 square root of 52 plus 2 square root of 52. No. We can finish that, or we can just leave it like that. So basically, we said B, I must have did some bad math, is 4 square root of 13. Well, they actually factored out 4. 52 divided by 4 is 13. So you've got 4 square root of 13 over 3 is what that equals to. That's what they did there. And they found B. And if you wanted to find this whole side, you simply would add this to square root of 52 and combine. Okay? So the code for this lesson, lesson 26, is you need to write the number 399 on homework 24 and do the practice problems.